Hello dear student, welcome to your new session of laws of motion. In last class we'll discuss about frame of reference, and I'll tell you frame of reference is of two types. One is inertial frame of reference and second is non-inertial frame of reference. And I already tell you dear student that frame of reference is nothing but position of observer. So if observer is accelerating, then we are considering it to be non-inertial frame of reference. And if observer is non-accelerating, then we can consider it as inertial frame of reference. And I'll tell you in last class that if observer is in non-inertial frame of reference, then the process for making free body diagram is, let's suppose a train is there, and the train is accelerating in this direction and an observer is sitting in this train. Now see my dear student, if train is accelerating and a block is placed in platform and the condition of this block is at rest. The condition of this block is at rest and a observer is sitting in a train and the train is accelerating. So if train is accelerating with a acceleration, then it is but obvious that the observer is also accelerating with the same acceleration what train is. So dear student, this observer is now in non-inertial frame of reference. Non-inertial frame of reference. Now see, under the condition of non-inertial frame of reference, what I'll say you how to make the FBD. Just imagine yourself to be at this platform. Now if you are seeing this block is at rest. Make the FBD of this block under rest condition. So vertically downward it is mg and in upward direction a force is acting on this block. That force is called normal reaction force. Now see, if the observer is accelerating, that is in non-inertial frame of reference, then what we'll see, we have to apply a force in negative direction of acceleration of observer. So if observer is accelerating in this direction, then we have to apply a force in this direction with force is equals to mass of object into acceleration of observer. If you remember about the last class, if you are not, then go through the last class first, then conclude this thing my dear student. Because if observer is in non-inertial frame of reference, means if observer is accelerating, then the free body diagram is not only with mg or normal. We have to apply one more force opposite to direction of acceleration of observer, and that force is in backward side. Now see dear student, what basically thing is, if you are sitting in a train or in a bus, the bus is going like this. Just watch the trees, or we can say electric pole, which is present on road, which is at rest condition. But if you are moving in this direction, what you will see? You will see that the trees, the poles, electric poles are going backward. But actually that basically pole or tree is not actually performing motion, but it appears to perform in motion. If you are aware with this thing, just imagine when you are sitting in bus or in your car or in your bike, in train, if train is moving like this, then the tree, or we can say the electric pole, which is actually in rest condition, is appear to moving back. So we can say the tree or pole, electric pole, is not in motion, but it appears to be in motion. So my dear student, under that condition, physics can give us a new concept called pseudo force. So write down next heading, it is pseudo, P-S-E-U-D-O, pseudo force. Basically pseudo force is an imaginary force. Imaginary force which acts on object which acts on object if observer is in non-inertial frame of reference. If observer is in non-inertial frame of reference. Non-inertial frame of reference. And my dear student, the direction of pseudo force, the direction of pseudo pseudo force is always opposite to the direction of direction of motion of observer, opposite to the direction of motion of observer. So remember my dear student, first thing, basically pseudo force is applicable when motion in imaginary. I'll write this point also. This force is acting on body. This force is acting on body when the motion is imaginary. When the motion in is imaginary. So remember this thing. First thing, when pseudo force is applicable, first of all, just conclude the thing. Basically, if I am sitting in train and train is accelerating, a block is present at platform, the block originally at rest condition. But if observer is accelerating in this direction, you will feel, or we can say observer feel, that this block is moving in backward direction. Why happens this beta? Because the observer is in non-inertial frame of reference. So if the observer is in non-inertial frame of reference, then the object which is actually at rest appears to be in motion. So we can say the object is not actually in motion but appears in motion. There is an imaginary motion, my dear student. There is a false motion takes place by object with respect to observer if observer is in non-inertial frame of reference, or we can say if the observer is in accelerating frame of reference. So if observer see this object is moving in backward direction. So we'll say the object is performing imaginary motion. In that condition, we will introduce a new concept, a new force called pseudo force. This force is applicable only if the observer is in non-inertial frame of reference, or we can say the observer is accelerating. And remember, the direction of pseudo force is always opposite to direction of motion of the observer. If observer is moving in this direction, then pseudo force is applicable in backward side. Remember this thing, pseudo force is applicable only if observer is accelerating. In that situation, we will say observer is in non-inertial frame of reference. And what is the value of pseudo force? It is ma. So pseudo force means mass of object multiply acceleration of observer. Remember this thing. Pseudo force is basically equals to mass of object multiply acceleration of observer. My dear student, remember, I am repeating once again because this pseudo force concept give you somehow a very good approach for numerical to solve the numerical. See, first thing, so when pseudo force is applicable, pseudo force is applicable if the observer is in non-inertial frame of reference, that is observer is accelerating. Now what happened, what is the condition in which pseudo force is applicable? So if the train is moving like this, in platform, if box is there, the box appears to move in backward direction. Actually the block is at rest, but it appears to be in motion. Why? Because the observer is in non-inertial frame of reference. If observer is standing behind the block, then observer says that the block is at rest. This is basically inertial frame of reference, because under condition of inertial frame of reference, observer acceleration is 0. So see my dear student, this block will appear to move in backward direction. So there is an imaginary force, and we know that if motion is there, then there must be some force. So we'll say if imaginary motion is there under non-inertial frame of reference, we have to apply an imaginary force. That imaginary force is called pseudo force. It always acts on particle opposite to the direction of motion of observer, and its value is mass of object multiply acceleration of observer. Remember this thing. Without pseudo, you can also solve the question, but with pseudo, the question will become easy. So remember, when pseudo force is applicable if observer is accelerating, that is under non-inertial frame of reference. What you have to do for applying pseudo force? Just make FBD under rest condition of observer. Like if I am standing here, with respect to me, the object is at rest. So vertically downward mg and vertically upward normal reaction force. Now again, then after making free body diagram under inertial frame of reference, that is at rest condition, apply a force in opposite to the direction of motion of observer, and that force basically is pseudo force. So conclusion is, pseudo force is valid for imaginary motion, first thing. Second thing, pseudo force is applicable under non-inertial frame of reference, means if observer is accelerating, then we'll apply pseudo force. So moving forward, my dear student, let's make another concept to understand more about pseudo force. So write down next topic, lift block system. Write down lift block system. Lift block system. This concept will be studied by us in two different conditions, one with pseudo force and other without pseudo force. Answer becomes same, my dear student. I'm just showing you, if you are applying pseudo force, then the questions become easy. So write down lift block system. Our next topic is lift block system. Lift block system. Without pseudo force I am solving this, my dear student. So this is basically case first. Okay, lift block system is also called, dear student, apparent weight. So write down apparent weight. Apparent weight. Lift block system is nothing but apparent, also called apparent weight. So case first is, if observer is at rest, or we can say inertial frame of reference. Inertial frame of reference. So see, my dear student, I am doing case first. If observer is at rest, or we can say in inertial frame of reference. So first case is if the lift is at rest. If the lift is at rest. Now see, my dear student, if there is a block, if there is a lift in which a block is placed and observer is in inertial frame of reference, means observer acceleration is 0, or we can say observer is standing on ground. Now see, if lift is at rest, then acceleration of lift is 0. So if lift is at rest and acceleration of observer is 0, my dear student, why? Because we are considering inertial frame of reference. In inertial frame of reference, observer is always at rest, or we can say the acceleration of observer is 0. Now case first is if lift is at rest. So if lift is at rest, then if observer see about if observer see the lift, then observer says the lift is at rest. If lift is at rest, then the block which is present on lift is also becomes at rest. So in this situation, observer make FBD. So vertically downward it is mg, and in upward direction there is a force called normal reaction force. So if observer says lift is at rest, then I must say or we can say observer say the block is also at rest. So if block is at rest, then we know that this condition is basically nothing but condition of equilibrium in which opposite forces are equal. So we can write N is equals to mg, simple, because this condition is of equilibrium, and equilibrium opposite forces must be equal. So this is all about case first, if lift is at rest. Moving forward, my dear student, case 2, if lift is in motion, or we can say if lift is accelerating in upward direction. If lift is accelerating in upward direction. Now see, this is our lift and a block is placed inside the lift of mass m, and lift is accelerating upward direction. We are considering all the cases in inertial frame of reference in which the acceleration of observer is 0. Now see, if I am making the FBD, vertically downward it is mg, and there is a force which is called normal in upward direction, because if mass is there, then weight is applied by the block on lift, then lift apply a force, normal reaction force, because we know that if two bodies are physically in contact with each other, then a force is acting called normal reaction force in upward direction. Now see, lift is moving in upward direction. I am standing here and I am seeing this lift which is moving in upward direction. So if I am standing here and lift is moving in upward direction, what we'll say? We'll say the lift is moving in upward direction. And there is a block which is placed on lift. Now see, my dear student, if block is placed on lift, lift is accelerating in upward direction, then it is but obvious that block is also accelerating in upward direction. So if block is moving in upward direction, so we can say now F net is equals to ma net, because the block is moving in upward direction. Two forces are there, one is upward force and one is downward force. So we can say F net means bigger force minus smaller force is equals to ma net. So what we'll get? We'll get normal minus mg is equals to ma. So what we'll get? Normal is equals to ma plus mg. So normal equals to m common a plus g. This is the value of normal reaction force, that is normal is equals to m a plus g. M a plus g, my dear student, if lift is moving in upward direction. Now see, if your experience is there in lift, and if lift is moving upward, my dear student, you feel your weight will be increased. This is practical application, my dear student. If you are standing in lift and lift is moving in upward direction, then this is basically practical application that you will feel your weight is increasing. Why weight is increasing? Because acceleration due to gravity is present. So normal is equals to ma plus g. That's why if lift is moving in upward direction, we feel that our weight is increasing. Moving forward, now I am discussing case 3. If lift is moving in downward direction, if lift is moving in downward direction, if lift is moving in downward direction, so let's suppose this is a lift, a block is placed inside the lift and lift is moving in downward direction with acceleration a. I am standing here, my acceleration is 0 because we are considering observer to be inertial frame of reference. So vertically downward it is mg, and in upward normal reaction force. Now see, my dear student, if lift is moving down, then observer says okay, lift is moving down. And if lift is moving down, then it is but obvious the block which is placed inside the lift is also seen to moving down. So if lift is moving down, the block which is placed on the floor of lift is also seen to be moving down. So we'll apply F net is equals to MA net. So F net means bigger force minus smaller force is equals to MA net. So bigger force is mg minus normal is equals to MA. So normal is equals to mg minus A. Remember one more thing, my dear student, acceleration due to gravity is always greater than the normal acceleration. In this situation, what we'll get? N is equals to mg minus A when lift is moving down. When lift is at rest, then it is but obvious the block which is placed on the floor of lift is also becomes at rest. So opposite force is equal under the equilibrium condition. If lift is moving up, then the formula then the value of normal reaction force is ma plus g. And if lift is moving down with acceleration a, then the normal value is mg minus a. Remember, g is always greater than a. This is the condition why if lift is moving down, my dear student, you feel your weight is decreasing. Why? Because normal getting by subtracting g minus a. So my dear student, if lift is moving down, then the value of normal is mg minus a. If lift is moving up, then the value of normal is ma plus g. So this is basically lift block system under inertial frame of reference. Now I'll solve same thing in non-inertial frame of reference. And non-inertial frame of reference means observer is accelerating. So moving forward, write down case 2. If observer is accelerating, write down case 2. If observer is accelerating, try to understand this concept, my dear student. Concept is nothing but frame of reference. Frame of reference means observer. In this situation, we'll discuss when observer is at rest, or we can say the acceleration of observer is 0. Now we'll consider the acceleration of observer is there, that is how to solve the questions with non-inertial frame of reference. So let's discuss the concept called non-inertial frame of reference. So lift block system under non-inertial frame of reference. So I am solving this concept lift block system under non-inertial frame of reference. Non-inertial frame of reference means now the observer is accelerating. Just try to understand, my dear student, how I am solving this concept. So case first is if the lift is at rest. If the lift is at rest. So see, my dear student, this is a lift, a block is there, mass m, lift is at rest, so the acceleration of lift is 0. Now consider observer to be inside the lift. Inside the lift. Now make the FBD. It is vertically downward mg in an upward direction normal. So if lift is at rest, then see, my dear student, I am standing inside the lift and lift is at rest. So if I am standing inside the lift, what I'll say? I'll say the block is at rest. Because if you are sitting in a bus and behind you one more person is sitting on bus is moving. So if any person is standing on ground, he or she will say you are in motion or your neighbor is in motion. But according to you, your neighbor is at rest, because with respect to time, the position of your neighbor is not changing. So apply similar concept here. So if I am standing inside the lift, I am saying the block is at rest. So if block is at rest, then this condition is called equilibrium condition, because forces is acting but still the body is at rest. So if forces is acting and body is still at rest, then we'll say the forces are in equilibrium. So if forces are in equilibrium, then we'll write normal is equals to mg. Now case 2. if lift is moving with an acceleration a downward. Let's suppose if lift is moving down. So write down case 2, if lift is moving down. If lift is moving down. If lift is moving down. So see my dear student, if lift is moving down with acceleration a block is there whose mass is m. Now remember dear student, if you want to apply pseudo force, you have to consider yourself on the accelerating system. Write down in form of note. Write down in form of note. First, write down in form of note. For applying pseudo force, you have to consider yourself inside the accelerating object. You have to consider yourself inside the accelerating object, because we know that pseudo force is only applicable if the observer is in non-inertial frame of reference. So my dear student, I am standing inside, I just imagine that observer is standing inside the lift and lift is accelerating in downward direction. So see dear student, if lift is accelerating in downward direction, then it is but obvious that the observer is also accelerating in downward direction. Because if you are sitting on a train and the train is accelerating, then it is but obvious that if train is accelerating, then you are also be in acceleration. So here I am placing observer inside the accelerating object. Here accelerating object is lift. Now the observer is standing on lift. Now see, I am making the FBD vertically downward, it is mg. In upward direction there is a force called normal reaction force. How to apply pseudo force? Pseudo force is apply, make the FBD under inertial frame of reference, then apply a imaginary force opposite to direction of acceleration of observer. Now see, observer is moving in downward direction. So if observer is moving in downward direction, its acceleration is in downward direction. So pseudo will be applied opposite to direction of acceleration of observer. It is ma. Remember, this ma is nothing but pseudo force, pf. I'll write pseudo force to be pf. Now see, if observer is standing on lift and lift is moving in downward direction, with respect to observer, the position of this block is not changing. So we'll say, the observer say this block is at rest. So if this block is at rest, then it is but obvious that opposite forces are equal. So N plus Ma must be equal to Mg. Dear student, try to understand thing. Basically, the observer is standing inside the lift. Lift is accelerating, but with respect to observer, the condition, or we can say the position of block is not changing. So observer says this block is at rest. And if block is at rest, then it is but obvious that opposite forces are equal. So N plus Ma is equals to Mg. So from here, we'll get the formula of N. It is Mg minus Ma. So N becomes equals to Mg minus A. See, same answer will become with inertial, without inertial. But if you are applying pseudo force, the concept become easy. But remember, what is the process for applying pseudo force? We have to consider ourselves, or we can say observer is consider himself to be in accelerating object. Here the accelerating object is lift. Now moving forward, we are discussing case C. If lift is moving in upward direction, if lift is moving in upward direction, so here comes, this is a lift in which a block is there and lift is moving in upward direction with acceleration a. Now I am applying pseudo, so I am considering myself inside the lift. So vertically downward mg, normal reaction n. Now how to apply pseudo force? First we have to make FBD under inertial frame of reference, that is if observer is at rest. So if observer is at rest, he'll make vertically downward mg and normal in upward direction. Now apply pseudo force opposite to the direction of motion of observer. So the direction of motion of observer is in upward side, so pseudo must be in downward side, and it is ma, that is mass of object multiplied by acceleration of observer. Now see, with respect to observer, the block cannot changes its position. So observer says the block is at rest. Instead, the lift is accelerating, but the observer is present inside the lift, which is accelerating. So with respect to this observer, the block remains at rest. So observer says the block is in equilibrium, and equilibrium means opposite forces are equal. So N is equals to mg plus ma. So N is equals to mg plus a. This is the value of normal reaction force with pseudo force, my dear student. So what we'll see? We'll see if you are applying pseudo force, means you have to consider yourself inside the accelerating system, and after applying pseudo force, the question, or we can say the format of question, become easy. So try to apply pseudo force. If the system is accelerating, consider observer to be accelerating system, then make FBD under normal condition, that is under inertial frame of reference, then apply a force, imaginary force opposite to direction of motion of observer. It is equals to mass of object multiplied by acceleration of observer. So after applying pseudo force, you will see here, my dear student, that the concept become easy, the things become easy. Now we will solve a question with the help of pseudo force. So try to understand pseudo force. If you are not understanding pseudo force, it means the concept of frame of reference is yet not clear. So go through the video of frame of reference, then come back again with this lecture, then only you will understand. So see, my dear student, there is a question. I'll solve this question with the help of pseudo force. Try to understand what is the method, how I am applying pseudo force. So see, question is, a block is kept, write down the question. This question is asked in JEE 2005. The question is asked in JEE 2005. So they are saying that an inclined plane is there whose angle of inclination is theta. A block is there whose mass is small m and the mass of inclined plane is capital M. This inclined, the angle of inclination is alpha. The question is, if this inclined plane is accelerating in this direction, if this inclined plane is accelerating in this direction, then what will be the value of this acceleration, so that this small block which is placed on inclined plane remains at rest. So write down the statement of question. A block is kept on a frictionless inclined surface with angle of inclination alpha, full stop. The inclined plane is given an acceleration A. The inclined plane is given an acceleration A. The inclined plane is given an acceleration A to keep the block stationary. To keep the block stationary, to keep the block stationary, to keep the block stationary, then A is equals to, then A is equals to, A means acceleration, then A is equal to, your options are, A option is G by 10 alpha, G by 10 alpha, B option is G cosec alpha, G cosec alpha, C option is G, and D option is G tan alpha, G tan alpha. So my dear student, try to understand the question. Question says there is an inclined plane whose mass is capital M. On the inclined plane a mass is there and the inclined plane is accelerating. So they are asking what is the value of acceleration of this inclined plane so the block remains at rest. So my dear student, if the inclined plane is accelerating in this direction, see, I am solving this question with the help of pseudo force. Try to understand what is the format for applying pseudo force, how to solve the questions with the help of pseudo force, because if you apply pseudo force, then the solution of question become easy for you. So see my dear student, they are saying what is the value of this acceleration so that this block remains at rest. So just make the free body diagram of this block first. I am making here free body diagram of block, only block, dear student. So this angle is alpha and acceleration is in this direction. Block is there. Mass of block is m. Now see, we know that for inclined plane, this is our x-axis and y-axis. As we know, vertically downward a force is acting, that force is mg. Now see, if this angle is alpha, then this angle is also to be alpha. In upward direction, normal is acting. We have to make the component of mg, because we know that mg is a kind of weight, weight is a force and force is a vector quantity. So if any vector quantity is making angle, then we have to split its component. For any vector, dear student, we know that two components will be formed. One is cos, another is sine. Cos component is always acts on that line along with the help of angle is formed. So here it is mg cos alpha, and in this direction it is mg sine alpha. So this is all about how the forces which is acting on body. Now see my dear student, in question they are saying what is the value of acceleration of this inclined plane so that the block remains stationary here. So my dear student, if you are seeing, then normal is countered by mg cos theta, mg cos alpha, I am sorry, normal is countered by mg cos alpha, and we know that along this direction motion is not possible. So in this direction forces are in equilibrium. So we'll write n is equals to mg cos alpha. Now see, there is only one force which is acting in downward direction. It is mg sine alpha. If mg sine alpha is not countered by opposite direction force, then this weight is moved in downward direction, my dear student. But in question they are saying what is the value of acceleration of inclined plane so that the system remains, the block remains at rest. So see, this inclined plane is accelerating. I want to apply pseudo force. So very first thing for pseudo force is, imagine yourself to be on accelerating object. So I am imagining myself to be in this inclined plane. Now see, if the inclined plane is accelerating in this direction, then I am also accelerating in this direction. In question they are saying what is the value of this acceleration so that the block remains at rest. So you want to block remains at rest. So my dear student, if I am moving in this direction, then what I'll say the direction of pseudo force must be opposite to direction of motion of the observer. So direction of motion of observer is in this direction. So pseudo must be opposite to the direction of acceleration of observer. So the direction of acceleration of observer is in this side. So pseudo must be apply opposite in this side. So in this direction we are applying pseudo force, that is MA. Now see, M is mass of block and A is acceleration of observer, and the acceleration of observer and the acceleration of inclined plane is same, because the inclined plane is accelerating on this accelerating object I am standing. So my acceleration is in this direction, or we can say the acceleration of observer is in this direction. So we'll apply pseudo in backward direction. Now see, if this angle is alpha, then this angle is also to be alpha. Again, pseudo force, this is basically nothing but force, my dear student, and we know that force is a vector quantity. So if we are seeing here, then force is making angle alpha, so we have to split its component. Any vector quantity forms two components, both components must be perpendicular to each other. So we have to split the component of pseudo force, because this mg sine alpha must countered by some force in this direction, otherwise this mg sine theta will take this block in downward direction, and in question they are saying find this acceleration so that the block remains at rest. So apply pseudo. See, the pseudo force is making angle with this line. So this line, along this line, the cos component is present, that is MA cos alpha, and along this line, one more force is there, MA sin alpha. This is the component of pseudo, my dear students. So instead of n is equals to mg cos alpha, now we have to write n is equals to mg cos alpha, because two forces is there, plus MA sin alpha. Now they are saying that the block remains at rest. So see, in this direction there is a force MA sin alpha, in this direction there is a force mg sin alpha. The block remains at rest according to question, so both becomes equal. So what we'll write? We'll write MA cos alpha is equals to mg sin alpha, because if the system is in equilibrium, or we can say if the block is at rest, then system is in equilibrium, and in equilibrium opposite forces must be equal. So MA cos alpha must be equal to mg sin alpha. Similarly, n is equals to MA sin alpha plus mg cos alpha. So from here m and m get cancelled. A cos alpha is equals to g sin alpha. Let cos comes this side. So A is equals to g sin alpha by cos alpha. Sin by cos, we know that it is equals to tan. So A is equals to g tan alpha. This is your answer, my dear student. So try to understand each and every concept. Pause the video, go through the video again and again until and unless you can't understand. This is how we'll apply pseudo force, my dear students. Pseudo force makes easy the concept. For applying pseudo force, remember the observer must accelerating, that is you have to consider yourself on accelerating system. This question is basically related to pseudo force. Without pseudo force, this question is capable, you are capable to solve this question, but with pseudo force the questions become easy. That's why I'll apply pseudo in this question, my dear students. So this is all about today's lecture. In next lecture, we'll discuss more concept and more numerical. Try to understand frame of reference, then go through this video. If you are not aware with frame of reference, then you cannot understand this concept, how we are applying pseudo force. Remember, pseudo force is an imaginary force which is applicable if observer is in non-inertial frame of reference. With the help of pseudo force, you can solve the question in easier form. Without pseudo force is also question is you are capable to solve the question, but the method becomes more complicated. So apply pseudo force. How to apply pseudo force? Consider observer to be on accelerating frame of reference and apply a force opposite to direction of acceleration of observer. That's it. You have to make the FBD and conclude that thing. Remember, for Newton's laws of motion, to understand the concept of Newton's laws of motion, you must aware how to make the free body diagram, what are the basic funda for making the components of any vector. Here we have two different components. One is of weight and other is of pseudo force. So thank you so much, my dear student. In next class, we'll discuss some more topic and some more numericals. Till then, stay happy, stay safe. Thank you so much with connecting with us. Stay in.